Hey, good day and welcome to Trig Functions in Standard Position, Part 1. So what we're going to do is I'm going to pull up a grid here, and I'm going to draw a terminal arm. Let's say my angle, and I'll just say it's angle theta, swings up this way, and let's say it goes like that. Okay, so there's theta, and there's my terminal arm. Now let's say, because we're on the grid, I actually worked out the coordinates of this point. And let's say it was 4 to the right and up 3. So let's say it has these coordinates. All right. Now I'm going to do something new and exciting. I'm going to make a little right triangle out of this thing. So try to draw a perpendicular line straight down. And I could actually think of this as a little right triangle with 90 degrees and angle theta. And I know this side here, I know its length is 4 to the right. And I know this side here, since we went up 3, would have a length of 3. And I can figure out this hypotenuse through Pythagoras' theorem. So if I just quickly plug all that in, I go, well, hypotenuse squared would equal the sum of the squares of the legs. So I do that. So that's going to equal 16 plus 9. Okay, so hypotenuse squared is 25. Well, guess what? That means the hypotenuse is 5. So now I've got everything I need to define the sine, cosine, and angle of theta. So the sine of theta is the opposite side. So opposite from theta is 3. Divided by the hypotenuse, which is across from the right angle. So the hypotenuse is 5. So there's the sine. There's the cosine in just a moment. Cosine is adjacent side, so 4 divided by hypotenuse of 5. And then I could even get tangent of this thing. So tangent of theta is equal to opposite over adjacent, so that is 3 divided by 4. Okay, nothing too earth-shattering so far, other than I drew this thing on the grid here, and I'm working in quadrant 1. Now, what is important is that, yes, we're in quadrant 1, and look at our trig results here. These all turn out to be positive numbers. This is going to be important later on, but for right now, I'm just going to summarize with an A and say they are all positive. Okay, so quadrant 1, all of them are positive. Okay, so you're probably thinking, oh yeah, I wonder where this is going. Well, let me tell you. I'm going to clear the screen, and we're going to build the same kind of thing over here in quadrant 2. So let's clear the screen. And to make it really easy for ourselves, I'm going to use basically the same triangle. I'm just going to flip it over to here. So this time I'm going to say, well, maybe I went 4 to the left and then up 3. And then I build my little right triangle here. Okay, so I went 4 to the left. Now, even though normally with lengths we don't think of them as negative, it is kind of helpful to say, why don't we think of that as negative 4? And then this is still positive 3. And when I use Pythagoras' theorem, the hypotenuse turns out to be 5. Now, there is a reason for this that I labeled it as a negative number, partly because it matches what we're doing on the grid here. And also later on, you'll see it kind of gives us a bit of a shortcut for some of our trig conclusions. Now, first of all, yeah, I didn't tell you, theta's actually here, isn't it? It's not even in the triangle. So, boy, how does that work? Well, here's the scoop. This is your terminal arm for theta, and this is your reference angle, and there is a relationship between the reference angle and theta. You know, they're not just random angles. They are related in that they are supplementary to each other. So when we look at our trig functions, we actually use the reference angle if theta's on the outside like this. And so now I can look at cos theta and sine theta and tan theta. Okay, even though theta is on the outside, but the reference angle is on the inside. So what do we have here for sine? We have 3 over 5. Okay, no big deal there. Cosine, you notice how it's now negative 4 over 5. Yeah, okay, so cosine is actually now to be considered negative. And tangent would also be considered negative because it's 3 over negative 4. So it's negative 3/4. So notice that when we got into quadrant 2 and we built up our trig triangle using the reference angle here, you'll notice that the only one that stayed positive was sine. So that was the only one that's still positive, whereas the other 2 trig functions have gone negative. Okay. Now, keep that in mind. I am going to clear the screen and build up basically the same little triangle. I'm going to build it in quadrant 3. So let's go 4 to the left and then down. So we're going down 3. So this is negative 4. So 4 to the left and then negative 3. Okay, and you know, if you use Pythagoras, you'd square these numbers when you add them up, so you're still going to get a positive hypotenuse. Now, theta, yes, is technically this whole angle, but it doesn't really concern us because we're going to be building off the reference angle, which is this little guy that's in our triangle. Okay, so what do we have here? Well, I think we can probably speed it up. Sine is going to be negative 3 over 5. So it is a negative 3/5. The cosine of theta is going to be negative 4 over 5. So it is also negative. And it is the tangent this time that is going to be a negative 3 over negative 4, which turns it into a positive 3/4. So in quadrant 3, only the tangent was positive, right? The other 2 have gone negative. Now, let's clear off the screen, and we want to look at quadrant 4. So, quick look at that, and then we'll summarize it for you. So we're going to build our triangle over here. Okay. Right angle there. So again, I'm going to go 4 to the right. This time, because I'm moving to the right, I'm considering it positive 4. And we're still heading down here on the y, so I'm going to call that negative 3. The hypotenuse is still 5, so let's have a little look. Oh, and by the way, theta is this guy here, right? There's theta, but here's our reference angle inside the triangle. Sine of theta would be negative 3 over 5, so that's negative. Cosine of theta is positive 4 over 5, so that's now gone positive. And finally, tangent of theta is equal to negative 3 over 4, so it's negative. So here's the conclusion in quadrant 4. Only the cosine is positive. The other 2 are negative. All right, now what I'm going to do is summarize it, and that's where we're going to stop here. So let's clear the screen and give you a quick summary of what you have just seen. If you have a terminal arm that ends up in quadrant 1, all of the trig functions are positive. If your terminal arm, doesn't matter how many loop-de-loops you make, if you end up in quadrant 2, then you will find only the sine is positive. If your terminal arm is in quadrant 3, only the tangent is positive. And finally, if you're in quadrant 4, only the cosine is positive. Now, a lot of students memorize this by just knowing the so-called cast rule. Okay? What it does, if you spell the word cast, right, C-A-S-T, then it tells you wherever you end up, wherever your terminal arm is, it tells you exactly which trig function is going to be positive and which ones are negative. And this is going to be important later on when we try to deduce some different things in some of these trig questions. So I won't give it all away. I think that's probably enough for today, and we'll pick it up with more on this later on.